Welcome back to the second part of this camera tutorial. If you missed the first video, you can find the link in the info card or in the description. Today we cover input maps, rotation by keys, detect when the mouse left the window, smooth zooming, adjust scroll speed when zooming, and we implement movement by dragging with the mouse. The setup from part 1 has changed slightly. This time I'm using the desert scene because it's more fun that way. The code is unchanged. My name is Julian, and without further ado, let's start into the tutorial. Let's replace the direct key bindings by those from the input map, because input maps are far easier to maintain. They are also very handy and easy to use, so it's not a problem if you don't know how to use them. After this step, you will. Input maps are located in the project settings. Godot comes with a few preset actions, but for practice we will create our own. We need actions for rotation as well as forward, left, right and backward movements. Then we need at least one key for each action. The big advantage of input maps is that you can change the keys at any time without having to change the code. Simply click or type into the Listen for Input field to detect what you want to assign to an action. In a small project, it is not that important, but since input maps are based on strings, I put the keys into a static class. This makes them much easier to maintain, especially if they are reused in other classes. I call the class custom actions because that's what it contains. I use the class because I can simply rename the content of the variables without having to change the variable name, like in an enum. This is especially useful if you're working with a version control system like Git. Using static classes in this way is helpful. They do not contain important logic, and we have a kind of contract that can reduce errors to typos. Back to the camera class. It's time to replace all direct input checks. But we keep the isReleased since there is no need to change it. Let's check if it works. Okay, time to implement rotation via keyboard. We can reuse lots of the existing code. We only need to extend it a bit. First, the action keys. Then, let's extend the camera class. For better separation, I add new variables and path them to the rotation method depending on the player's input. Reset the direction variables after usage outside the method because they are now independent from the input. And we are ready to take a look. Nice! Mouse and keyboard do not affect each other. I would say that's fine. It's really annoying when the game does not run in full screen and the camera keeps scrolling when the cursor has left the window. Let's make it better. All we need to be able to fix that is a variable for the state and a listener for the mouse exit and the mouse enter notifications. Now we're able to use the state to ignore the input while the mouse is outside the window. Much better. Now it's time to improve the zoom. You may have noticed in the first video that the zoom is a bit jerky. If not, you'll probably find out when you try it yourself. This is because the values are not interpolated, so let's smooth them. We only need to write the desired zoom in a variable, then pass it into a lerp method inside process before it is assigned. Play around a bit with the time value of the lerp method. In my opinion, 0.2 works very well. The handling feels much better now. Next, let's speed up scrolling depending on the zoom distance. But before we proceed, I'll quickly add categories to keep the exported variables organized. I keep the speed variable and rename it to base speed, because we will calculate the modified speed based on its value. Then I add a curve as modifier, since it allows us to adjust the values more precisely. By default, the values of the curve are distributed between 0 and 1. In order to query a sample for the current zoom, we must first calculate the steps. I add the modified speed to the base speed, so the value never falls below what we have configured as base speed. Let's add a curve and set some values for testing. It's fun to play around with the values and see what works best. At last, we will implement movement by dragging. Again, we can reuse a lot of the code. I will also add toggles to disable dragging or edge scrolling, as both together makes the code more complex and could confuse the player. Add a new action to enable dragging. And let's first bind it to the right mouse button. Then we set the direction depending on the mouse delta, similar to what we did with other functions. Finally, we reset scroll direction and we're done. But note that we can only reset the value if dragging is enabled, otherwise edge scrolling will only work while the mouse is moving. Here is how it would look like. Now it's fixed. Then let's have a look how it works when dragging is enabled. A bit fast, I think, but this can easily be changed with the scroll parameter. Since we didn't add a separate variable, for drag speed, scrolling with the key will also be slowed down. Let's fix it, and then we'll restructure the code a bit. That's it for part 2. I hope you enjoyed the tutorial and were able to follow me. There is still more that could be added, such as ground detection, tracking a target, or scroll speed acceleration. Maybe I'll cover this in another video. Please let me know in the comments if you have any suggestions or improvements. Till then, thanks for watching.